Today we're going to cover part of Chapter 6, Section 5. Today all we're going to do is graph the cosecant and the secant graphs. Tomorrow we're going to graph the tangent graphs, which are also part of these notes. So we're only going to go through part of them today. So the first thing we're going to do is take a look at the cosecant graph. So the cosecant graph, remember this is the reciprocal of sine. So we're not used to seeing it spelled out like that. We're used to the abbreviation, which is the CSC. So when you graph the cosecant graph, what we're going to do is we're going to graph the sine graph first, and then we're going to draw in asymptotes, and then we're going to draw in these blue parabola looking things on each of the maximum and the minimum points. So the dashed line there in the picture or in the slide, that's the sine graph. You're going to graph it first, and then from there, what we'll do is we're going to graph either the cosecant graph, if it's a sine graph, or if it's a cosine graph, we'll be graphing the secant graph. Now, just to show you how this comes all about and where we're going to be drawing in our asymptotes, if you think about the unit circle, and just looking at the axis points, so the 0 and the 2 pi, the pi over 2, the pi, the 3 pi over 2, and add in each of these ordered pairs here, 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 negative 1. So remember, whenever we do sine, remember when it was the unit circle, we just looked at y, but when we're using the axis points, we're going to do y over r. So let's say I wanted to do sine of pi. So pi, I'm using the ordered pair negative 1 comma 0. So I would put in 0 over 1, and it equals 0. So if you look at your graph up here, when you find pi, notice the sine graph, it's on 0. So at pi, the ordered pair is pi comma 0. Then if you plugged in, let's say we did cosecant. If I did cosecant of pi, remember we flip it, and then this now becomes 1 over 0, which is undefined. So notice for pi over 2 for the cosecant, that's where we have an asymptote. So what we're going to be doing is we're going to go ahead and graph the sine graph. Then we're going to add in asymptotes at every spot that my sine graph touches the x-axis. So notice my sine graph touches it here, 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 and here. And that's where all of my asymptotes are located. And if you were to go ahead and do this, you would find that the value of that is going to be undefined. So for example, if I did sine of 2 pi, cosecant of 2 pi, again, cosecant r over y, notice 2 pi uses this ordered pair, and it's 1 over 0, and again, undefined. So every spot that the sine graph touches the x-axis and it equals 0, the cosecant graph is going to be undefined. And that's going to be the location of all of our asymptotes. Once we graph the sine graph, so you're going to graph the sine graph just like normal. So notice the sine graph, we would be graphing y equals sine of x. Remember, the sine graph always starts at 0, 0. And then from there, I can go ahead and it would go normally up if it's a positive sine graph, then down and up. And again, where all these red points are, that's the location of my asymptote. And then now at each one of these maximum and min points, that's where you're going to add in these parabola shapes. So then this is a maximum. I use the asymptotes as my guide and draw in a parabola. And then at the minimum, same thing. Same thing here and here. So the graph of the cosecant is in blue. So if when you're doing this, if you're not using colors on the test or the quiz, what you could do is just shade over the purple here and say, well, this one isn't part of my graph. What the final graph is all the blue. I do have colored pencils I could pull out, but you have to be careful with the colored pencils because they're hard to erase. All right, everybody good? Now, what helps some of the students is when you go to graph this, I want 2 cycles of this. So a lot of students are going to draw a box around it and box it in. And then right over here is 1 cycle. And that's to the left of the y-axis. And this is my other cycle. So let's go ahead and take a look at the secant graph. And then we're going to do examples. So for the graph of the secant graph, we're going to graph cosine first. And again, notice this time, notice my parabolas on the ends are sort of cut off. So this is where it helps. Normally a cycle of cosecant or sine and cosine is 2 pi. So right here, this would be 1 cycle. And I can box it in. And then this would be my other cycle. So if when you go to draw these parabolas, if it helps you to draw the box, then when you go to make the whole U shape, you can sort of see it. I don't need to see what's out of the box. So I don't need to see this, but if it helps you to draw it in there and box it, you can do that. So for this secant graph, what we're going to graph first is going to be y equals 2 times the cosine 1/2 x. So this is what was on the test. So remember, the number in front is the amplitude. This is my b value. So b equals 1/2. So this is going to be, when it's a fraction, this is going to be a slower speed. So remember, the normal cycle length or period length for cosine and sine is 2 pi. So I'm going to take 2 pi, divide it by 1/2. I'm dividing it by the b. So remember, it's 2 pi divided by b. So 2 pi over 1 divided by 1/2. Keep change, flip it. And it becomes 2 over 1. So 4 pi is going to be the length of my period. It's going to be slower. So now, again, you're still multiplying. There's no phase shift here. So we're going to do 4 pi times 1/4, 4 pi times 1/2, 4 pi times 3/4, and 4 pi times 4 over 4, which is just the period length. So here, once I multiply 1/4, notice the 4's cancel, so you're just left with pi. Over here, this would simplify as well. This becomes 2 pi. And then here, the 4's simplify, and 3 pi. Remember, whenever there's not a phase shift, the left side of the y-axis are going to be the same numbers, but with a negative sign. So let's go ahead and set up everything, and we're going to graph the cosine first. So I'm going to go ahead and draw my axis here. So I have my first point, which is pi. Over here would be negative pi, 2 pi, negative 2 pi, 3 pi, and then 4 pi. And then I have an amplitude of 2. Now, if you want to start by boxing it in, this is the only spot that I'm looking for the graph here. Now, I need to graph the cosine graph. Remember, cosine always starts at the amplitude. So I'm going to start up here at 2. And then it's going to go down at pi. And then down here at 2 pi. Back up. And then up here. And then I can repeat the pattern. Here, 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 and back up again. So let me go ahead and graph this in here. Now when you do this, you shouldn't be making straight lines. It needs to have a little bend to it, because this is a curve. All right, so that is y equals 2 times the cosine of 1/2 x. Now the question wasn't asking you to graph the cosine graph, it wanted you to graph the secant graph. So now what I need to do is draw in my asymptotes. When you do this on the test or the quiz, I want to see the asymptotes drawn in. So every place that the cosine graph touches the x-axis, I'm going to draw an asymptote. So I have one here, I have one here, here, and here. Those are my asymptotes. I'm going to use those asymptotes as my guide. Now, in order to draw the secant graph at the maximum and the minimums, I'm going to draw in my parabolas. So this is a maximum, so I would be drawing my parabola shape right here and right here. Now, I don't need to see what's out of the box, so I'm really only graphing this one. Let me use a different color. Maybe blue. So there is that one. And then down here at this minimum, using the asymptotes as a guide. And then over here. And then this one only bends in. So my cosecant graph, my cosecant graph is all of this. Everything that I just went over in gray. You can leave it all there. So if you're not using color pencils, or if you wanted to do like the notes had, do the cosine graph as a dashed line, and then you can go back and do the solid line for the reciprocal. Or what you could do is you could just go over this one and say, this isn't part of the graph, and just shade over it. Okay, we also have another one right here going up in the middle here. So again, remember these asymptotes keep going on up. So at every maximum and min point, you need to put in that parabola shape. All right, so for this one, remember whenever you have a parenthesis and there's something inside it, this is going to be the shift left and right. And it's backwards of what you think. So this minus pi is actually a shift to the right to pi, which is 180 degrees. Notice the negative sign here. This is going to be a negative sine graph because this amplitude is -1. So what I'm going to graph first is going to be y equals negative sine of x minus pi. I'm going to graph this one first. I need to calculate my order pairs or my points. Remember this time when it's a shift left and right, we don't use the 1/4, the 1/2, the 3/4. I need to space all of these 90 degrees apart. So I'm going to take my starting point, which is going to be pi. So if I take my axis here, let me come down here so it doesn't get into the colors. So I'm really starting right here at pi. I need to get my next point, which is going to be 90 degrees away from that. So what I'm going to do is take pi, and I'm going to add pi over 2. I need to find a common denominator. That common denominator is going to be 2. So this becomes 2 pi over 2 plus pi over 2. So I get 3 pi over 2. So remember, this is actually 270 because pi is 180. I'm spacing these 90 apart. And if you think about your circle, the next point is going to be 2 pi. But let's go ahead and take 3 pi over 2, add pi over 2, 4 pi over 2, which simplifies to 2 pi. Now, remember, this is my starting point right here. This is where I'm starting. I need 4 points that are going to be to the right of that. So I need to do this 2 more times. So I'm going to take my unsimplified fraction, the 4 pi over 2, add pi over 2, 5 pi over 2. So that's my next point. Do it one more time. I get 6 pi over 2, which simplifies to 3 pi. Now I got to go in the other direction. So now I take my pi and I subtract pi over 2. I can't just make all of these negative. Now, this was not on the test. We did not do phase shifts on the test. It'll be on your next testing quiz. So then now, common denominator, 2 pi over 2 minus pi over 2 gives me pi over 2. Notice my next point is right here. And let me move this over. Is my point to the left of my starting point is still positive. It's not a negative number. But remember, each one of these is spaced pi over 2 apart, or 90 degrees apart. And if you think about it, pi over 2 is 90, and pi is 180. So that's why it's still 90 degrees apart. Now if I take pi over 2, subtract pi over 2, notice I get 0. 0 is a stopping point. And then I'm going to do it one more time. Subtract pi over 2, and I get negative pi over 2. So then my next point is over here. And I still got to do it. I've got 3 points that are to the left. Let me do it one more time. And then I get negative 2 pi over 2, which just simplifies to negative pi. So my graph sort of looks lopsided. But what you need to remember is this is where we're starting. And I got 4 to the left, 4 to the right. Okay, so again, remember, you need 4 points. And my starting point is here, it's at pi. And then you need 4 points to the right. So these are points to the right of the start. These are to the left. Now I'm going to go ahead and add in my amplitude. It was -1. So really I'm just going to put a -1 and a +1 here. Now remember, the sine graph always usually starts at 0, 0. But we're now starting at pi on the x-axis. So my starting point is right here, where I wrote the little word start, and then I just put the red dot. And then from there, it goes to the amplitude. And my amplitude was -1. So at 3 pi over 2, it goes down. Then at 2 pi, it goes back up. Then at 5 pi over 2, it's even higher up here at 1. And then back at the axis at 3 pi. Then I can go ahead and repeat my process. So at pi over 2, it's right here. And then 0 was the stopping point at this phase shift. It's not always going to be a stopping point. And then down, and then back up again. So this is what you had to do in the homework that is due tomorrow morning. This is the phase shift of the sine graph. Now we're going to do the phase shift of the cosecant graph. Once you get the sine graph graphed, now we can add in our asymptotes. Now, if it helps you to box in your graph, because remember, we don't want to go outside of our cycle here. So this is where my graph is going to be located in this box. I'm going to draw in my asymptotes. I have asymptotes at all of my x-intercepts. So I have one right here, 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 and here. And now you're going to use those max and min points to draw in your parabola shapes using the asymptotes as your guide. So now my cosecant graph, I'll do it in purple. So I've got a minimum that's right here. Right here, and it's going to go down. I got a maximum up here, goes up. I got a minimum here and a maximum here. And there's your cosecant graph.